Hi everyone, welcome back. In this video, we will discuss top 10 Spring WebFlux interview questions and answers. Let's begin. What is Spring WebFlux and why was it introduced? Spring WebFlux is Spring's reactive and non-blocking web framework built to handle massive concurrency with minimal resources. Unlike Spring MVC, which follows a thread per request model, WebFlux uses an event loop architecture based on Reactor's mono and flux types. It was introduced to support modern applications that need high scalability, such as microservices, streaming systems, and real-time applications. Traditional blocking I/O struggles when thousands of users connect at the same time because each request occupies a thread. WebFlux solves this by using non-blocking I/O, making it possible to handle many concurrent requests with fewer threads. In interviews emphasize that WebFlux is ideal when responses depend on asynchronous data sources like APIs, data buses, or message queues. It gives high throughput, low latency, and efficient resource usage. Next question. What is the difference between Spring MVC and Spring WebFlux? Spring MVC is synchronous and uses blocking servlet APIs, while Spring WebFlux is asynchronous and non-blocking. In Spring MVC, each request is tied to a dedicated thread. If the thread waits for a database call or API response, it stays blocked. WebFlux uses an event loop architecture. It never blocks threads while waiting for responses. Instead, it resumes processing when the data arrives. Spring MVC uses Java types and returns objects directly, while WebFlux uses mono for single results and flux for streaming multiple results. Use WebFlux when your architecture requires scalability, real-time data, streaming use cases, or cloud-native workloads. Use MVC when your application is primarily synchronous and relies on blocking libraries. Next question. What are mono and flux in Spring WebFlux? Mono and flux are the two core types in Project Reactor, the reactive engine behind WebFlux. Mono represents a stream that emits 0 or 1 value. It is used when your endpoint returns one item, such as fetching a single user. Flux represents a stream that emits 0, 1, or many values, even infinite streams. It is used for lists, streams, or continuous data sources. Both are asynchronous, lazy, and non-blocking. They support operators like map, flat map, filter, delay, merge, zip, and more. Interviewers expect you to mention that mono and flux replace traditional return types and enable non-blocking pipelines. Next question. How does the request handling model in WebFlux work? WebFlux follows an event-driven model. When a request arrives, it does not immediately bind it to a thread. Instead, the request is passed through an event loop. If an operation is slow, like a database query or calling another API, WebFlux does not block. It registers a callback and releases the thread to handle other requests. When the result is available, WebFlux resumes the pipeline and sends the response back to the user. Because of this model, WebFlux can handle thousands of concurrent requests using only a few threads. Next, what is the role of router functions and handler functions? WebFlux supports two programming models, the annotation-based model and the functional model. In the functional model, router functions define routes using a functional style instead of annotations. Handler functions contain the business logic to process requests. This style is useful for applications that prefer immutability and functional programming concepts. It also gives precise control over request routing. Interviewers may ask when to use it. Choose functional routing when building lightweight microservices or when you want a more expressive and testable routing system. Next question. How does WebFlux achieve non-blocking behavior? WebFlux achieves non-blocking execution by using the Reactor event loop, reactive streams backpressure, asynchronous non-blocking I/O through NATI, Undertow, or Servlet 3.1 containers, Instead of blocking a thread when waiting for the data, WebFlux registers callbacks. Backpressure allows consumers to control how fast data is produced, preventing overload. WebFlux's entire stack, from HTTP layer to reactive database drivers, supports non-blocking operations. Next, what is backpressure in WebFlux? Backpressure is a mechanism in reactive streams that prevents producers from overwhelming consumers with too much data. For example, if a data source emits values faster than the client can process them, backpressure signals the producer to slow down or pause. Flux supports backpressure natively, allowing safe streaming between services. In interviews mention that backpressure improves stability in high-throughput systems where data flow control is critical. Next, which servers support Spring WebFlux? WebFlux supports multiple servers, both servlet-based and non-servlet-based. Netty is the most common choice because it is fully non-blocking and event loop based. You can also use Undertow, Jetty or Tomcat with Servlet 3.1 non-blocking I/O. However, using Tomcat reduces some non-blocking advantages since it mainly relies on Servlet APIs. Interviewers expect you to mention that Netty is the preferred runtime for true reactive performance. Next, can we use blocking libraries inside WebFlux? Why or why not? Blocking libraries should be avoided because they break the event loop model. A single blocking call, such as waiting for JDBC operations, will hold a thread and reduce scalability. Instead, WebFlux encourages using reactive drivers such as R2, DBC for databases or WebClient for calling external services. If blocking is unavoidable, Spring provides bounded elastic schedulers to isolate blocking code. But in an interview, the correct answer is blocking breaks the non-blocking architecture and leads to thread starvation and performance degradation. Next, what is WebClient and how is it different from RestTemplate? WebClient is the reactive, non-blocking HTTP client in Spring WebFlux. It replaces a RestTemplate, which is blocking and synchronous. WebClient can handle both single responses and streaming responses using Mono and Flux. It integrates perfectly with WebFlux for reactive end-to-end pipelines. RestTemplate holds a thread while waiting for the response, but WebClient frees the thread and resumes the execution when data arrives. Interviewers expect you to explain that WebClient is the modern choice for microservices and high-performance applications. So these are the top 10 interview questions and answers on Spring WebFlux.